Continuing lesson 7.1 on Pythagorean theorem. If you look on page 383, example 3, Mara is repairing the trim on one side of a display case sketched at the right. She has a piece of trim that is 20 inches long. Does Mara have enough trim to repair the display case? So if you look at the picture there, once again, hypotenuse is across from the right angle. If you want to make this into an arrow that points to the hypotenuse, you can do that. So 29 inches is the hypotenuse. We need to make sure that goes in place of the C in our equation. And the other side, the 20, could go in for either A or B. Since they have a B still sitting over here that we're trying to find, they went ahead and replaced the A with it. But they can put any letter for what it is we're trying to find. They don't have to use A, B, or C for the letter. They can put an X or something if they want. So once we substitute those numbers, the next thing we always need to do is go ahead and square them. So 20 squared, 20 times 20 is 400. 29 squared is 841. Our goal is to figure out what B is equal to. It's going to take us still a couple steps to get there. The next thing we could do is get the B squared by itself. So you can see on the side with the B squared, they are adding. So we need to subtract. So instead of writing everything what the book did there, if you wanted to just subtract 400 on both sides, which is 441, that's B squared. We want to figure out what B is equal to. So at this point, we do the opposite operation. So, you know, they're adding, we subtract, they're subtracting, we add, they're multiplying, we divide, they're dividing, we multiply. They are squaring the variable. We need to take the square root. So square root, when you add the square root, we'll go ahead and put plus or minus there. Even though a negative answer is not going to make sense in this case, we can go ahead and cross it out. That's fine. Some cases, if you're just solving an equation and a random equation, negatives are allowed. Some cases, negatives are okay. So encourage you to put the plus or minus there and just cross out the negative. And then if you take the square root of 441, you could do that on your calculator. Maybe that would be 21. So she needs 21 inches of trim, and it says she only has 20 inches, so she does not have enough trim. So the try it at the bottom of the page, again, they're wanting us to find one of the legs of this triangle. If you want to draw the picture out, you can, if that helps you to visualize. It says the hypotenuse is 32 meters. One leg is 18 meters. I don't know necessarily if that's the shorter or the longer side, and I don't really care too much at this point. We're just trying to find one of the legs. And if they give me an option here, kind of, I'm going to probably have A be what I'm trying to find. I just like the look of that better with the variable first, but that's up to you. The main thing, the important thing, is we put 32 in place of the hypotenuse here. And then we need to go ahead and square these numbers. So 18 squared is 324. 32 squared is 1024. And then they're adding on the side with the variable. So we need to subtract 324 from both sides, which is 700. And then we can take the square root, again plus or minus, even though the negative's not going to work here. And this says express your answer as a square root, so we're just going to leave it as the square root of 700. I'm kind of curious to know what that is, just so I make sure I did the problem correctly. If you did the square root of 700, it would be kind of close to 26. The reason I'm interested in that is I want to make sure, since that's one of the legs, I need to make sure it's not bigger than the hypotenuse. If it's longer than the hypotenuse, then I made a mistake somewhere. Also, we could look at the two legs together should be longer than the hypotenuse, because It's a shorter distance to go in a straight line between 2 points than it is to go like down and over there. So 26 plus 18 for sure is more than 32, so that should be good also. Key concept, just recapping again, Pythagorean theorem, a squared plus b squared equals c squared. C is the hypotenuse. Page 384, if you look at number 3, Xavier said the missing length is about 18.5 units. Without calculating, how can you tell Xavier solved incorrectly? Well, the missing length here, if that's 18.5, the problem with that, look at your other lengths here. What we're trying to find is the hypotenuse. Hypotenuse should be the longest side, but it's actually shorter than either one of these. It's got to be bigger than both of these. In other words, hypotenuse has to be bigger than 28. So that's how we could know that we made a mistake there. Number 4, they're just giving us a problem here again. If you want to draw a picture out, you can. This time they're wanting us to find the hypotenuse. The legs are 4 and 5. So if we square those, we can add those together since they're on the same side. The c squared by itself, but we do need to take the square root. We can do plus or minus there. Negative doesn't make sense. And they want us to write our answer as a square root and to the nearest tenth of an inch. So as a square root, it would be square root of 41 inches. And then nearest tenth, if you take the square root of 41, nearest tenth would be 6.4 inches. And that's longer than the 4 and the 5. It's longer than both the legs, so that should be good. Number 5, similar idea, only we're finding one of the legs here. This time they didn't even put a letter there on the side. We just know it's the missing side. So whatever you want to do, I'm going to make it be the A. And again, the important thing, the 14 is the hypotenuse, has to go in place of C because it's our longest side. If we don't put it there, we're not going to get the right answer here. So square both of those. The a squared is not by itself yet, so they're adding. We can subtract 64 on both sides. And then they are squaring, so we take the square root. Plus or minus, negative is not going to work. This time they are just wanting us to write this to the nearest tenth. So nearest tenth would be about 11.5 feet. Okay, it's like 11.48 something. So we bump it up. It's closer to 11.5 feet. Workbook page 90, number 6. What is the length of the hypotenuse of the triangle when x equals 3? Round your answer to the nearest tenth. So x equals 3. Probably what we would want to do here first is just substitute in place of the x. So if x equals 3, this would be 2 times 3, which is 6. This would be 15 plus 1, which is 16. So my two legs are 6 and 16, and I'm trying to find the hypotenuse. So even though this looks a little intimidating at first, after we do some substitution, it's really not any different at that point than what we've already done. So the 6 and the 16 are the legs. We square those, and then they're on the same side, so we can go ahead and add those together. and then they're squaring, so we'll do the square root plus or minus. We can cross out the negative, and this says the nearest tenth. So if we do the square root of 292, comes out to about 17.1. And they didn't tell us feet or anything like that, so we'll just say about 17.1 units. Number 8, Dylan places a ladder against a wall. The base of the ladder is 5 feet from the wall, and the ladder is 12 feet long. How high will the ladder reach? If you're doing a problem like this, please draw a picture. It doesn't have to be a perfect picture, but some kind of a picture so we can see what's going on. So the base of the ladder is 5 feet from the wall. So this is 5 feet. The ladder is 12 feet long. And we're seeing how high the ladder reaches up on the wall. So this is what we're trying to find. We're trying to find one of the legs. If you can tell, this would be a right angle here. So the 12 feet would be our hypotenuse. Okay, what happens, we do these problems, then people work something out like this, and we have some kind of a ladder that's got to be floating in the air somehow, because it's a 12-foot ladder and it's like, 15 feet off the ground that it's reaching. It's hitting this building. I wouldn't want to stand on that ladder. So let's make sure we don't have any levitating ladders here. 12 is the hypotenuse. We square those, and then they're adding. We can subtract 25 on both sides. And that's 119. And then they're squaring, so we can do the square root plus or minus, even though we know a negative answer is not going to work. And we'll just round this. They should have told us, but we're just going to round this off to the nearest tenth is what they're doing. So that's about 10.9 feet. Okay, again, it better be less than 12 feet off the ground, because it's only a 12-foot ladder to begin with. And then part B, how will shortening the distance between the base of the ladder and the wall affect the dimensions of the triangle? Basically, if it's closer to the wall, then this leg will be shorter. And then this leg will be longer. So, this was 10.9 feet that it could reach up. The closer we get to the wall, the closer to 12 feet that's going to be. Again, for stability purposes, we really don't want to have the ladder going close to or straight up and down, because then it's just going to fall when we stand on it. So this gives you an idea about understanding the Pythagorean theorem.